Okay, so go ahead and start copying the notes for today's lesson that are on the screen. Miss Antoine, go ahead and start collecting homework number 3. It was due today at the beginning of class. Remember, students, that if you are going to turn it in with a partner, that both you and your partner's name is on it. Please collect it at the beginning of class. After you have collected majority of them, stop collecting them. At that point, it is considered late, and I will not accept it. The next thing is that I hope that you know how to behave. If by any chance Miss Antoine leaves me a negative note, then of course you need to keep in mind that I have not written your test for Friday, and I will definitely write it a lot harder if I get a negative note. Fifth period is already at that level, and you don't want to join them. Next thing are seats. I realize that some classes are bigger, for example, fifth period and second period. So if there are people absent after Miss Antoine has checked roll, if you want to see better, then you can go ahead and ask her and she will allow you to sit at an empty desk. If you do need extra chairs or desk, which I don't think so, Miss Antoine, I do have some additional desks and chairs in the closet in my classroom. Only you are allowed to go back there. Next thing, no one leaves my classroom unless it's a pass from the office that has called out for you. And then finally, please, no one at my desk except for Ms. Antoine. All right, so let's go ahead and start with today's lesson, which will be involving inverse trigonometric functions. The first thing that I want to go over is notation. Notation is very important with this because I will use it simultaneously. So for example, the inverse cosine notation is the same thing as if I said arc cosine. Likewise, inverse sine notation is the same thing as arc sine, and inverse tangent is the same thing as arc tan. Traditionally, your professors are a lot older, so they will use this method right here. Books have started to shift to this method, especially because you briefly discuss inverse functions in Algebra 2, or at least you should have, and that's the way they denote an inverse. Remember, if you went over it in Algebra 2, that I would give you a function f of x equals something, you would change it to y equals whatever, you would swap your y's and your x's, and then you would solve for y one more time. Once you solve for y, you would replace that y with the inverse notation. That's how it would work in Algebra 2. So that's exactly what we're going to be doing in this case. Okay, so before we do that, let's go ahead and just go over a couple of definitions and stipulations. Um, in order for a function to have an inverse, it has to be 1-to-1. So it has to pass the horizontal line test. If you think about it, the cosine and the sine curves are waves that continuously go on forever. If you placed a horizontal line anywhere on that graph, it passes or it crosses more than one time. So therefore, we need to put some stipulations on it, which is why we have these stipulations right here. So arc sine only exists in quadrants 1 and 4, in which negative pi over 2 is between y, and which is between pi over 2. So on the y-axis, it goes from negative pi over 2 to positive pi over 2. Arc cosine lives between in quadrants 1 and 2, between 0 and pi on the y-axis. Arc tangent exists in quadrants 1 and 4, between negative pi over 2 and positive pi over 2 on the y-axis. So I'll give you some time to go ahead and just finish writing those notes. Okay, so let's continue. That is a brief sketch of arc sine. If you notice, it does follow those stipulations from negative pi over 2 to positive pi over 2 on the y-axis. Next is a brief sketch of arc cosine. And of course, you can see that it's from 0, which is down here, all the way to pi on the y-axis. And then, of course, the next one is arctangent, and it is from negative pi over 2 to positive pi over 2 on the y-axis. You won't be graphing these, so if you didn't get these sketches, we'll go over them again on Thursday or sometime next week. But as long as you kind of have an idea as to how they look like, that's perfectly fine. So let's continue. The most important thing here that you have to remember again is San Antonio Tequila Company. So if you're in quadrant 1, all of the trig functions are positive. If you're in quadrant 2, the only one that is positive is sine and its reciprocal, which is cosecant. If you're in quadrant 3, the only one that's positive is tangent and its reciprocal cotangent. And then if you're in quadrant 4, the only one that's positive is cosine and its reciprocal secant. So let's take a look at an example. Find the values of arc sine of negative 1/2. You have to think about this differently. Now, traditionally, what I've done is I have given you an angle. So, for example, I have given you sine of 30 degrees. Well, that's very easy because I know that if you have sine, that is the x or the y coordinate. It's the y coordinate. So what you would do is you would go to your unit circle, look up 30 degrees, and look at the y coordinate of 30 degrees, and that would be your answer. Now I'm going backwards. Now I'm giving you that x or y coordinate, and then depending on that, you have to go on your unit circle, if it's a nice number or a nice angle, and figure out which angle it's going to be. And you could either give me the angle, of course, in radians or in degrees. So let's take a look at this one. It says arc sine is negative 1/2, or arc sine of negative 1/2. So if you think about it, I am going to translate this into something that I know how to do. So the way you translate it, and I remember doing an example. If you remember, the example was on your homework in regards to the lake and the bike path with the tower. We had to find the angle theta, where we had to eventually do the inverse. That was preparing you for today. So the way I transpose this, or I retranslate it, is that I have my trig, which is sine. I'm looking for my angle theta, and that is going to equal whatever is inside this parentheses, which in this case is negative 1/2. Okay, well, if you go back, arc sine only lives in quadrants 1 and 4. Perfect. Okay, so keep that in mind. Quadrants 1 and 4. Well, here, sine of whatever angle is negative 1/2. Well, think about it. Go back to San Antonio Tequila Company. Arc sine only lives in quadrants 1 and 4. So here and here. Well, in that case, where would my sine be negative? It wouldn't be negative here because A stands for all of them being positive. It would be negative here. Perfect. Well, in that case, I'm looking for an angle in quadrant 4 that will give me the y coordinate, because sine is y, negative 1/2. So let's go to our unit circle. Okay, so let's go here to quadrant 4, where y coordinate is negative 1/2, and it is 330 degrees. So that is our answer, 330 degrees. And of course, it produces what kind of triangle? So from here all the way up to my angle is 330 degrees. Well, I know completely around is 360. So that means 360 from 330, this little piece right here is 30 degrees. So this has formed a 30, 60, 90 right triangle. But the answer is 330 degrees. Let's look at the next example. It's saying that the inverse sine of square root of 3 over 2. Well, what I'm going to do is I'm going to transpose this again into something that I do know. So basically this is saying, at what angle is sine equal to square root of 3 over 2? Well, let's think about it. And keep in mind, look, this time I used the inverse notation compared to the arc sine, but it's the same thing. Arc sine or inverse sine only exists in quadrants 1 and 4. Well, this time my answer is positive. So if you go back, here is 1 and 4. Okay, so my sine answer is positive. So where is sine positive? In this quadrant. So we're actually in quadrant 1. Okay, so basically what we're saying is if we're in quadrant 1, I'm going to have a sine value. In other words, your y-coordinate will be square root of 3 over 2. Well, let's take a look at it. So here's quadrant 1 right here. My y value will be square root of 3 over 2. And the only angle that is true is either pi over 3 or 60 degrees. So that will be my answer. Pi over 3 or 60 degrees. And realize that this created a 30, 60, 90 triangle. Here was the 60 because it was in quadrant 1. Across from the 60 is the square root of 3. This is the 1 right here adjacent, and the hypotenuse is 2. Okay, next, arc cosine of square root of 2 over 2. Again, let's think about transposing it. This is really saying cosine of theta is equal to square root of 2 over 2. Well, if you think about it, let's go back to where arc cosine can live. And arc cosine can only live in quadrants 1 and 2. So keep that in mind, quadrants 1 and 2. Okay, so quadrants 1 and 2. So basically, when I transpose it, I said, I have an angle, and I'm going to take the cosine of that, and I'm going to get a positive value. So remember, arc cosine only lives in quadrants 1 and 2. So let's take a look. Here's 1, here is 2. Well, we're looking at cosine because it will produce a positive value. Where is cosine positive out of these two? Right here in quadrant 1, exactly. So what we're going to do now is, after that, we're going to go to our unit circle because it's going to be in quadrant 1, and we're going to look for the cosine coordinate, which is square root of 2 over 2. In other words, your x-coordinate. So let's check it out. So your x-coordinate in quadrant 1 should be square root of 2 over 2, and the only angle that has that is pi over 4, or in other words, 45 degrees. So this has created a 45, 45, 90 triangle, and your answer could either be in degrees or in radians. Okay, the next one, cosine of theta. That's not the right answer. That's not the right question. The question is actually arc cosine of -1. So what I did is I transposed that into cosine of theta is equal to, what's in the parentheses, -1. Okay, so ask yourself, where is cosine? In other words, where is your x-coordinate on the unit circle equal to -1? If you think about it, it really is at just 1 point. So let's go to our unit circle. So our x-coordinate is equal to -1. The only value where my x-coordinate is equal to -1 is right here, which is at pi or 180 degrees. So that would be my answer. At pi pi or 180 degrees. Okay, I'm going to go ahead and stop here and go on to the next video.